And this finally brings us to our case studies about spiral wound lining technologies. And we do have 1, 2, 3, 4, 5 case studies. So for all different types of spiral wound lining technologies, I can give you at least one case study. There will be also some videos, but also some information from my side. So let's start with A1, where we had a project in the province of Buenos Aires in Berazategui, I don't know how to spell it right. The pipe itself is about 120 years old. It's a circular shape with different diameters, but 2286 was one of the bigger diameters, and the total length is 600 meters. The liner ID chosen is 1800 millimeters. So there was a HDPE liner installed with the Sekisui SPR-PE technology. And the hose pipe condition class according to DWA is A3, since the pipe was already partly collapsed. And we also had a very high water level during the lining works. So this is somehow the big features of this project. Regarding the hydraulic capacity, so we had the flow capacity of the hose pipe of about 11.3 cubic meters per second to about 14.2 cubic meters per second. This different flow capacity is because of the different diameters of the hose pipe from 2100 to 2286 millimeters. And after the rehabilitation, we do have a increased flow capacity of 16.6 cubic meters per second. This is because of the very good roughness coefficient of our plastics profile, which we use for the spiral wound lining, what is much more better than, for example, for a concrete pipe, like in this case. So first of all, there's a little video from news television. And after this, I will show you a video from the construction company who performed this project in the province of Buenos Aires. So switching to full screen and showing you the video.
Hablamos ahora de nuevas obras que está llevando adelante AISA en Berazategui.
Sí, y dicen que con todos estos trabajos el servicio en la zona va a ser cada vez mejor.
Nosotros estamos ahora en el partido de Berazategui, estamos posicionados arriba de la primera cloaca máxima. Lo que estamos haciendo es le estamos haciendo una rehabilitación hidráulica y estructural a la primera cloaca máxima, que es el conducto que originalmente recolectaba todos los líquidos cloacales del micro y macrocentro y eran transportados hasta Berazategui para después ser descargados en el río. Reconstrucción del caño lo que te permite es, obviamente, alargar la vida útil del caño. Este es un caño que ya tiene más de 100 años, fue terminado a fines de 1800. Lo que estamos haciendo ahora es darle otro mínimo 100 años más de vida. El beneficio que trae es que al ser un caño de características modernas tiene menor coeficiente de rugosidad, con lo cual te permite transportar mayor cantidad de líquido por el mismo diámetro de caño. Las características del caño que nosotros mandamos a diseñar es que tiene que ser estructural, tiene que soportar por sí solo las cargas que tiene tanto arriba en el terreno como en las distintas trazas de la máxima, y además tiene que tener una característica de ser inerte al ataque de los gases que están presentes en los líquidos locales.
And now the video of the construction company for Everpipe.
Estamos en la localidad de Berazategui, donde estamos realizando la rehabilitación hidráulica y estructural de la primera cloaca máxima. Esta es una cañería que data de más de 120 años de antigüedad y debido a esto tiene un gran grado de deterioro, tanto estructural como hidráulico, en función de la cantidad de sedimentos que tiene. Lo que estamos haciendo para rehabilitar esta cañería es conformar una cañería dentro de la cañería existente sin afectar al funcionamiento. La ventaja principal de este sistema frente a otros sistemas tradicionales es la posibilidad de efectuar la rehabilitación de la cañería sin necesidad de realizar un zanjeo de la misma. Principalmente esa es una ventaja importante en este caso porque en la traza que vamos a rehabilitar hay construidas casas por encima de la cañería. Este proyecto consiste en la rehabilitación de 600 metros de cañería divididos en dos etapas. Una primera etapa de 200 metros de extensión y una segunda etapa de 400 metros de extensión. Para esto hemos realizado distintos frentes de ataque, tanto para el ingreso de personal como para el ingreso de la maquinaria, para realizar la rehabilitación de la cañería. Luego, estos accesos también van a quedar como bocas de registro que van a facilitar el mantenimiento y la limpieza de la cañería rehabilitada.
This brings us directly to SWO lining technology of the group A2. So there we have a project in Bogota, Colombia. It's a circular shape where we had hosepipe diameters from 200 to 550 millimeters. The total length of this project is about 23,775 meters. We had or have hosepipe condition classes from A2 to A3. The project is still running, and the depth of the invert is about 2 to 3 meters. We have soil and traffic loads to be considered, a groundwater level roughly 1 meter above the pipe crown. And the features of this project are the heavy damages, the sedimentations, the water level. So in some parts of the project we have nearly no water, and in some parts we have a very high water level. So this was and is still a tough job to rehabilitate. The flow capacity of the hosepipe prior to the rehabilitation was 0.021 cubic meters per second, and after the SWO liner is installed, it's about 0.036 cubic meters per second. There we have also a nice photo where you can see the very little site setup even in such narrow streets. You see the winding machine is lowered into the manhole, and the spool which provides the plastic profile to the machine is mounted on the truck, as well as the power generator and the hydraulic unit. So everything you need for the winding process at the starting manhole is just at this little space of one truck. And there we also have a photo of the winding process itself. So you see the machine lowered into the manhole. The steel wire, as you remember, we need the steel wire for this technology to cut the secondary lock, the working lock of the profile, to make the expansion process afterwards. And another photo showing the CCTV live footage. So when you install this technology, you typically use CCTV cameras to control the installation process, and especially to control the expansion process, because you need to have an idea how fast you pull the steel wire and how much profile you put into it. So there we also have a nice video.
La tecnología SPREX busca la restauración del flujo de las aguas negras mediante la rehabilitación Spiral Wound Pipe, cuyo significado es bobinado en espiral de la tubería. Para su implementación es necesario realizar un proceso riguroso que será explicado a continuación. Primero, se selecciona la tubería a rehabilitar. Segundo, se realiza inspección y lavado de la tubería con equipo Vactor y CCTV, con el fin de determinar colapsos u obstrucciones presentes. Tercero, Se alista la tubería, realizando eliminación de obstrucciones o defectos presentes en la tubería mayores a 2 centímetros de espesor con equipo Cutter. Cuarto, se realiza la medición de domiciliarias para, una vez finalizada la rehabilitación, reaperturar y conectar nuevamente la red. Quinto, de acuerdo con características propias de longitud y diámetro de cada tramo, se selecciona la referencia de cinta SPRX y accesorios del equipo para instalar. Sexto, nuevamente se lava el tramo con equipo backdoor a contraflujo con una presión de 1800 a 2000 psi para despejar y limpiar las tuberías de cualquier grado de colmatación presente. Séptimo, a la punta de la cinta de PVC se le realiza un corte desde la esquina con un ángulo de 60 grados y se corta hasta dejar en la cinta una punta. Se eliminan las imperfecciones de corte y se ingresa la cinta al drive hasta que se efectúe el posicionamiento de los rodillos para la formación de la espiral. Octavo, la cinta conformará un tubo cuyo diámetro de ingreso es 2 pulgadas menor al diámetro de la tubería. Esta ingresa con una guaya de 1 o 1.2 milímetros dependiendo del diámetro de la tubería. El ingreso de esta guaya permitirá la expansión y acople de la tubería más adelante. Noveno, se inyecta la cinta hasta llegar al pozo. Décimo, se expande la cinta hasta acoplarse a toda la tubería y así finalizar la instalación. Undécimo, luego de la instalación se realizan los respectivos cortes y se sella con cemento de secado rápido en toda la boca de la cinta. Duodécimo, finalmente se vuelve a entrar el cutter para aperturar y perfilar las domiciliarias del tramo rehabilitado con SPREX.
And this brings us to the spiral wound technology of the group B. There we have a project in Germany, in Mochau. The hosepipe is a circular shape with ID of 1200 millimeters. The hosepipe condition class here was A2, so it means big cracks but not this big deformation. The groundwater level was considered at 1.7 meters above the invert. And the features of this project where it is a culvert of a river, so it means river piping, and we had many deformation and ovalization inside the pipe. The length, since it's only a culvert of a river, was just 30 meters. And also here we like to talk about the hydraulic capacity before the rehabilitation with spiral wound lining was 2.54 cubic meters per second, and after the SWO liner was installed we had an increase of the flow capacity to 4.25 cubic meters per second. Also, I like to show you some picture of the site setup. As you can see, the access to the rehabilitation section was not this easy, but with spiral wound lining nearly everything is possible. And there you have a photo of the winding machine, and the profile is fed from behind. The machine runs through the pipe and winds the PVC profile directly to a closed fit liner, and this is the final pipe. And I have prepared a little video of this project as well. Yeah, then finally going to the spiral wound lining technologies of Group C, where we have another case study from Bogota in Colombia, a circular shape again. There the diameters were from 1,200 to 2,500 millimeters. The total length of this project is more than 5 kilometers, nearly 6 kilometers. Hosepipe condition class is A3 according to DWA. And the features of this project were extreme slope in some parts of the pipe and a very high flow speed of the water. So also here a hydraulic comparison. We had the flow capacity of the hosepipe of approximately 7.5 cubic meters per second, and after rehabilitating with our SWO lining technologies, we had an increase to 12.64 cubic meters per second. What you see here is a picture of the whole project, so it's quite long. And these are some pictures of the winding process, where you see that in these bigger circular shapes, we also use such guide frame where the machine is guided. This gives some more stabilization to the lining process, to the machine itself, and is typically tailor-made for each project. So such guide frame would be used, of course, also for non-circular shapes. And in the next picture we see a bracing system for the bigger circular shapes to protect the liner against deformation and buckling, and also against flotation. And if we have, for example, a smaller diameter, we just use such simple float protections. So there's only a beam in the bottom of the pipe and some simple float protection installed to protect the liner against floating during the grouting works. This pretty much depends on the size and how many layers of grout you use. We discussed this already. And also some picture of the site setup. So also this now is the grouting process, where typically the most space is needed. So quite good. So also there we have a little video. The video was originally a 360-degree virtual reality video, but for our presentation I tried to make 2D video out of it. So I hope that I cover it good, that you see everything at the right place. And let's go.
Comienza un nuevo día en una ciudad en donde se movilizan alrededor de 5 millones de personas por minuto y cerca de 700,000 automotores. ¿Has pensado cómo se solucionan los retos del agua en las grandes ciudades?
Satélite en posición. Enciendan luces.
Hoy existen nuevas tecnologías que nos ayudan a reducir los problemas de movilidad en la comunidad. Agilizar los procesos, a disminuir los impactos ambientales y afrontar de manera eficaz los retos que trae el crecimiento urbano. Nosotros, sin Zanja Pavco, trabajamos rehabilitando colectores y tuberías que ya han cumplido su vida útil, que presentan problemas funcionales o estructurales y que requieren ser intervenidas, reduciendo el impacto en la comunidad y en las personas.
Ok, todo preparado. Procedamos.
Cada proyecto es diferente y contamos con una tecnología para cada necesidad. En este proyecto estamos usando tecnología Spiral Wound, donde la rehabilitación garantiza las condiciones estructurales e hidráulicas del sistema.
Todo está bien. Por favor, continúe suministrando perfil, recogiendo mangueras y mantengan la velocidad del enrollado.
Después de nuestras jornadas de trabajo, tenemos una tubería completamente renovada, una estructura capaz de soportar las cargas establecidas en diseño y con nuevas condiciones operacionales. Todo esto logrado sin cortes en el servicio del agua y con la menor interferencia en las vías. Cada integrante de nuestro equipo está comprometido noche tras noche, velando por la tranquilidad de las personas y de manera casi imperceptible trabajan incansablemente hasta el nuevo amanecer. Así es como damos nueva vida a las tuberías.
Vigía, tramo rehabilitado a satisfacción.
And as mentioned, also another case study for the SWO lining technology from Reichenbach in Germany. So there we had to rehabilitate a mouse shape with a width of approximately 4 meters and a height of 3.2 meters. The hosepipe condition class here was considered as A3 according to DWA. And yeah, the features were a very difficult access, what you will see in the video as well. There was no bypassing possible, no overpumping possible, and we had a very, very strong bend of 5D, or let's say 110 degrees. High water level, high flow speed, a hard and tough project, but a nice one as well. Also here the hydraulic comparison, flow capacity of the hosepipe prior to rehabilitation was approximately 20 cubic meters per second. And the flow capacity afterwards, when the lining with the SWO liner was finished, were approximately 26 cubic meters per second, or are 26 cubic meters per second. So also in Reichenbach we did a 3D laser scan and used the evaluated data for making 3D models for detailed planning of each work step. Also a very complex static design. We heard this before in the sample for the static design. So it is very important for such big shape projects that every work step is really planned in detail and prior to project start. So the more you plan in advance, the better the project will run. So we also had to design a special winding cart, since the machine is very, very heavy in such big shapes, and you will see it in the video as well. And we also did a winding test prior to the project start. So where we tested the winding cart and also the winding machine with the profile, with the guide frame, what was tailor-made for this project. Yeah. And in this picture you see the liner design, like this one a little bit bigger for you as well. We had to install a steel reinforcement, as you can see. And yeah, this is because of the condition class of the hosepipe and because of the regulations in the DWA. And also some concrete rails. So this is the red marked part, which was needed to support the winding cart during the winding process and to support the liner as well. So this picture I like to show you is just the 3D design of the bracing system used at this project. So as you can see, it consists of bracing frames and bracing beams and some additional support beams inside the bracing frames because of its big size and shape. We had to use these, and also the two float protections, which were of course, as well as the bracing system itself, calculated during the static design. And another picture of the winding machine. But let's now start with the video of the Reichenbach project. So this SPR-TM spiral wound lining project took place in Reichenbach, Saxony, Germany. So it's in the eastern part of Germany. And there we were able to create a European record with the biggest pipe to be rehabilitated by spiral wound lining all over Europe. The pipe was built in the beginning of the 20th century, so 1911, 1912. And the size of the pipe is about 4 meters in width and 3.2 meters in height. And we had to make a complex static design, as you can see, using also steel reinforcement in the bottom. And then winded the liner with the SPRTM winding machine. And there you can see this yellow one is the guide frame, which guides the machine to the shape that was designed. And also we had to use a so-called winding cart, which holds the winding machine and the guide frame. And there you can see the 4 gearboxes used. And this all was done even under live flow conditions, so the machine is able to work in live flow. And as mentioned, we had to install steel reinforcement prior to the winding, and also some concrete support ways for the liner to be placed on. Afterwards, the designed bracing system was installed to bring the liner in shape, to protect it against deformation and also against flotation. So 2 float protections were installed. And finally, the grouting process took place, where we used the high strength concrete with 2 mixing units. And as you can see, it's a highly fluid concrete, which was installed in approximately 7 layers. So 7 days of continuous grouting, layer by layer. And there you can see the knocking test, what is typically done. That means this one is hardened, fresh, hardened, and even no grout backfilled. Yeah, and this was our Reichenbach SPRTM European record project. Thanks for watching. Yeah, and that's it so far for our seminar about spiral wound lining. We now have enough time for your questions and comments. So I'm looking forward to your questions, and thank you for joining this seminar.